Okay, so you'll notice that a sentence is written over here. Okay, this is Unit 2, Chapter Review. Okay, and it says, write the following as a conditional statement. A conditional statement has an if in it and a then. Okay, so I wrote, if two lines are parallel, then they don't intersect. So if is right here, then is right there. And then that's the conditional statement with if and then. It says underline the hypothesis once and put a box around the conclusion. So underlining the hypothesis, this part is a hypothesis, okay, and then this part is the conclusion. And remember, the if and then is not included in the hypothesis or conclusion. Okay, the next one is find the next three terms. Okay, so based off of this pattern, it's 4, 7, 11, 60, 16, 22, 29. And then, so we're adding 6, 7, then we add 8. Okay, we're going to add 9. Oops, sorry, it's 37, not 38. Then we're going to add 9. Okay, and then we add 10. This is a type of inductive reasoning. Okay, so it says given the following statements, all supplementaries add up to 180 degrees, we're going to write a conditional and then write what the converse is. Okay, so the conditional would be if, remember conditional, you add if into it, if two angles are supplementary, then they add up to 180. Oops, I put then. Then they add up to 180. Okay, and that would be true. Okay, and also the converse is we're going to do the same thing with if and then. Instead, and this time we're going to reverse the hypothesis and conclusion. And if you remember from before, this is the hypothesis. Okay, and this part is the conclusion, and they're about to flip. Okay, we keep the if and then, but we just flip the two statements so that it is if two angles add to 180, then they are supplementary. Okay, and then that's true. And so since they're both true, they can be biconditional. Okay, biconditional is a statement that works true both ways. Okay, if we flip it like we just did with these two sentences. And then you write an if and only if in the middle. So two angles are supplementary. If and only if. Okay, and that's where the biconditional is different than the other types of sentences, because this has the if and only if in the middle. If and only if they add to 180. Okay, so we're going to say, it says, using the law of syllogism, what can we conclude from this sentence below? Okay, so it says, what conclusion can you make from the syllogism? So law of syllogism is basically if two things equal to the same thing, they equal to each other. Okay, so this angle, if a pair of angles are a linear pair, they're supplementary. Okay, and then if they're supplementary, they equal 180. So I'm going to take out the part about supplementary because they both are equal to that. So that means that they're going to be equal to each other. Okay, so that means that these both are equal to each other. It says, given two angles form linear pair, then they add to 180, excuse me. Okay. And then the following, we're going to match what each one of these go to with the other on the other side. Okay, so subtraction property is basically you're going to be subtracting something from both sides. So, of course, subtraction property is G. Okay, we're subtracting something from both sides there. Reflexive property is something that is equal to itself. So, C. Okay, this is equal to itself. Distribution property, you're distributing here 3 into 2 and 3. So, 3 times 2 and 3 times 4 to get 6x minus 12. So, that's A. Symmetric property is basically they're going to flip, okay? So if you notice x plus y equals 4 is what they had first, and then it flipped into 4 equals x plus y. So that would be F. Transitive property of congruence is two things equal to the same thing, and so basically they equal to each other. So the transitive in this one is going to be E, because y equals z, and then x equals z, so that means that x has to equal y because, again, they equal to the same thing, so that means they are equal to each other. So let me erase all that. Addition property, basically you add something to add the same thing to both sides. And substitution property is you're going to be substituting one thing in for another. So for instance here, we're substituting in x for y, or the other way, okay? We're substituting in y for x here so that it ends up being substitution. Okay. Okay, so it says, what is the difference between property of equality and property of congruence? Okay, property of equality measures is equal measures. And congruence is same shape, same size. Okay, so for 13, we're going to do all these things down here for 13, and let's see if I can kind of zoom in there, and I'll just kind of go down as it happens. Okay, so it says state the hypothesis and conclusion. So the hypothesis, I'm going to go ahead and highlight it in yellow, is this part, or I guess I'm highlighting it in blue. Okay, that's the hypothesis. And then this part is the conclusion. Okay, the hypothesis is, again, you don't include if, you don't include then. So that's the hypothesis, that's the conclusion. So my hypothesis, I'm late to 5th period. Okay, and again, you drop the if, and you drop then. When you put this into, when you write this down, the hypothesis and conclusion does not have if or then. Okay, my conclusion is I am counted tardy. Okay, so converse, we're gonna put back the if and then, and this time we're flipping the hypothesis and conclusion. So if I am counted tardy, then I am late to 5th period. And yes, that is true. Okay, and in the inverse, this time we go back to the original, and instead of, and then we just put knots into it. Okay, so I'll go ahead and do a different color. So if, I'm going to go back to what the original statement was. Okay, the original statement is right here. Okay, I'll do in blue. If I am not late, late to fifth period. Then I am not tardy. I am not counted tardy. Okay, and that is also true. So contrapositive is going to be the combination of converse and inverse. So basically, I go back to the original. I flip it and put not into both of them. Okay, so go back to the original and flip it. So I'm going to first put the, if I am not counted tardy, then I am not late to fifth period. If I am not counted tardy, then I am not late to fifth period. Okay, and that is also true. Okay, so the fact that that it's true going in both directions, the original and the inverse, I can go ahead and count this as a biconditional. And the biconditional is if you put if and only if. Yes, it can be written as a biconditional because the conditional and the converse are both true. Okay, sorry, my handwriting. Okay, so the biconditional is I go back to the original and then I just drop the if and only if. Okay, remember the original was if I'm late to fifth period, then I am counted tardy. So I'm going to drop the if and then, and I add if and only if. Okay, so if, no. I am late to fifth period if and only if I'm counted tardy. Okay. Okay, so every time I have been to a football, every time I have been to a football game or, I'm sorry, I'm on number 14. If a team wins 10 games, then they will be in the finals. So Pierce won 10 games, and so that means they're going to be in the finals. Okay, that is deductive reasoning because that is something based off of a fact. It's probably some sort of a district policy or just some sort of a tournament policy that if you win so many games, you'll get to the finals. Okay, so every time I have been to a football game, it's it's at Mustang Ingle. Okay, and then that's called inductive. That's only because that's your personal experience. That's stuff based off of your observations. And so basically you're saying that every time, because you've been to every football game, it's always been at Mustang Stadium, all football games from at Mustang Stadium. So that statement is not necessarily true because that's just your experience. So inductive reasoning is based off of what you observe. Okay, given the conditional statement, decide if the statement is true, if the inverse, converse, and contrapositive, or if it's inverse, contrapositive, or what it says at the top of the page. Okay, so if it is a polygon of 4 sides, that it is a quadrilateral. That's my conditional. Okay, if it is not a quadrilateral, then it does not have 4 sides. That would be the contrapositive, because I took the original statement and flipped it. Okay, and the next one, if a polygon is a quadrilateral, then it has 4 sides. So I flipped it, so that would be the converse. I remember when I talk about flipping it or reversing it, I'm talking about going back to the original. So the original was, if a polygon has 4 sides, then it is a quadrilateral. This one is adding knots into the statement. That's going to be inverse. Okay. Number 17. So we're going to do these, do this proof just by filling in the blanks here, okay? So these are my givens, and those are usually the first things that I fill out. So I go down here at the statements and look for what is given. So this is given, and that is given, and that's what I'm going to write here. So that's given, okay? And then number 4 is also a given. So that takes care of a lot of our problems or our answers here on the right-hand side just by writing the givens in. So I'm going to erase all my marks here. And again, I already wrote down what was given. Okay, so angle 1 and 2, so here angle 1 plus angle 2 is equal to angle HGJ. Okay, so here's angle HGJ, angle HGJ. And if you remember, G is the angle in the middle, HGJ, okay? That is addition postulate. Okay, and again, I can look, that's the addition postulate. Sorry, angle addition postulate. Okay, because you're adding 2 angles together for it to equal to the one large angle. So angle. Okay, and there is a word bank up here, so angle addition postulate. And those are your options at the top. Okay, so now I have this that was in this original statement. Now I have this, so it got changed. Basically, it's substituted. Okay, I substituted one thing in for the other, so that's called substitution. Okay, and finally, okay, so I already had this as a given. I substituted here and here, and that was a given. Okay, so now I'm showing that this and this, these two are equaling to the same thing. So let me actually erase that, and then, so I'm just not writing all over the place. Okay, so you'll notice that both of these statements equal to 90. Okay, so if 2 things are equal to the same thing, they're equal to each other, that's called transitive property of equality. Okay, so down here, we're supposed to just match the different types of conditional statements. Okay, so we have the conditional statement, and then this is actually a good template. We'll give you this on the test, just so you can tell how everything goes, okay? So the conditional statement is going to be C, okay, A to B. If A, then B. The hypothesis is the part after if. Remember, it doesn't include if, okay? Okay, and then the part that's after then is called the conclusion, which is B. Okay, and then inverse is going to be putting not and not into it. So it's the conditional. Remember, this was the conditional, and then these are adding knots into it. That's the inverse, so that's E. Converse is when you take the conditional and you reverse them from each other, or reverse them. Okay, so again, this is my conditional, and then I'm reversing it here, and that's going to be converse. Excuse me, I think it said contrapositive. Okay, So now, the contrapositive is the combination of this and then adding the contrapositive, excuse me, is a combination of these two. Okay, you're flipping it and then you're adding the not and the not. So that is going to be F. And then finally, the biconditional has the arrows in it, indicating that the statement can be true in either way. So there's G.